Previous class we have started testing of samples. Various samples were discussed, whether it is a difference between sample mean or proportion mean, or a sample standard deviation, or population standard deviation. So let us continue with the same topic. Related to that, what we have to do today, that is F test of significance. Its other name is Snedecor F टेस्ट, दूसरा नेम है वेरिएंस रेशियो टेस्ट। ये इसके तीन नेम है। देयर आर थ्री नेम्स ऑफ दिस टेस्ट, Snedeker's F test. Now in this test we have to compute the ratio of the uh, variances S1 square and S2 square, and S1 square, S2 square are means, sorry, it is variances of two samples with the size n1 and n2, and its standard deviation is S1 and S2. Now we have to find out this ratio and decide accordingly. For finding out the ratio of this, we should have summation x minus x bar square over n minus 1, or s2 square is summation y minus y bar square upon n2 minus 1. This is the formula to calculate s1 square and s2 square. So, and one more thing, this is the population variance, this one. This is S1 square and this is S2 square. This is population variance, but this is a sample standard deviation. And sample variance is denoted by small s1 square and small s2 square. Now, let us discuss in the question. The question is, in two independent samples of sizes 8 and 10. So the first sample has a size 8, and the second sample has size 10. And the sum of the squares of the, this is given to us 8, and this is given to us 10. Sum of the squares of deviation of the sample values from the respective means are given to as 84.4 and 102.6. So this is given to us. This is x minus x bar square is 84.4, and summation y minus y bar square is 102.6. This is given to us. And the test whether the difference of variances of the population is significant or not. This is we have to test. So the null hypothesis we have to prove sigma 1 square is equal to sigma 2 square. That is, there is no significant difference. There is no significant difference between population variances, and its alternative will be opposite to that, that both are not equal. This is we have to fix. Now let us compute the value, and the value is s1 square is equal to sigma x2 minus x bar square, and it is divisible by n1 minus 1. So 84.4, and it is divided by 7, because the sample size is 8. 8 minus 1 come out to be 7. So ultimately it come out to 12.057. And similarly, s2 square is sigma y minus y bar square over n2 minus 1. So 102.6 divided by 9, it is 11.4. So these are the values of s1 square and s2 square. Under h naught, we can compute the value s1 square divided by s2 square. And after computing, you will be able to compute, you will be able to test the significance level. So this should be S2 square. So you will 12.057 over 11.4, and this come out to 1.0576. Now the question arises, always remember the greater value we have to take in the numerator. But I want to say the numerator value should be greater than denominator value, always. So if it is not so, then the formula will be written like this, S2 square over S1 square accordingly. So the which is the bigger value in between S1 square or S2 square, you have to take in the numerator. This is the definition of the Snedecor F test. Now this is the calculated value. We shall have to find out the table value from the F table at 5% level of significance. So the table value at 5% level of significance is to be determined for both degrees of freedom. First sample size is 8, so first degree of freedom is 7. Second sample size is 10, so second degree of freedom is 9. So this value is computed from the table, that is 3.29. So obviously the calculated value is less than tabulated value. F calculated is less than F tabulated, and you know that in that case null hypothesis is always accepted. So null hypothesis accepted means there is no significant differences between the population variances. So this is the procedure to compute the F. F is the ratio of the variances. If the sample values are given to us, so you can compute in that case S1 square, S2 square by calculating the mean deviation and then dividing it by n1 minus 1. You can do like that. Now, suppose in the question we have given the sample size as 12, and the second sample size is also 12, it is given to us, but the standard deviation of the sample is given 0.035, and the standard deviation small s2 of the sample is given 0.062. Now this is the different case. Again the null hypothesis we have to take sigma 1 square is equal to sigma 2 square. The null hypothesis in the questions of F test will always be same. There is no doubt about that. Now, in the question they have given that you have to test the level of, you have to calculate the F value and use the 5% level of significance for the specified degrees of freedom. But before this, we need capital S1 square. There is the formula for calculating capital S1 square. This is a new formula in which we shall use this sample standard deviation. So the formula is n1 over n1 minus 1 into S1 square. This is the formula we have, 12 over 11.035 square. So by this formula, we will be able to find out the value. Similarly, S2 square is n2 over n2 minus 1, S2 square. So 12 upon 11, it is 0.062 whole square. So now we have to compute the value of F. It is clear that S2 square is bigger, so you can use S2 square in the numerator, and this value will be cancelled with this. Ultimately, we should have 0.062 square, and it is divided by 0.035 square. Now by computing and finding out the value, you will get the value is 3.1379. You can compute. This is the calculated value. Now the table value, or you can write down tabulated value of f for degree of freedom, which is denoted by mu. Mu is the symbol we shall use. N1 minus 1 and N2 minus 1. That is the sample size is the same, so it will be 11. 11 at 5% level. And what it come out to be from the table, that is 2.83. And it is clear that f calculated is bigger than f tabulated. So if it is so, then the null hypothesis is always rejected. So in this case, the null hypothesis will be rejected. Null hypothesis rejected means alternative hypothesis will be accepted. So what is the alternative hypothesis? That both have different populations. So we can say that there is a variability. There is a variability in the variances of two population variances. So this is the way to compute F test. And it is very easy. These two formulas will always be used. Only sum of squares of deviations from the mean, and this is this formula. Either this formula will be used, or simple S1 or S2 small, if it is given so, then this formula will be used. And you have to use these formulas and find the exercise. Now, after F test, we have another important test, that is the chi-square test. CHISQUAR. Chi-square test. This is the symbol of chi and its square. So chi-square test will be used. And the best fit question will come under this section, that whether the fitting is the best fit or not. Now, how to uh, do the questions related to chi-square? It is very easy. Suppose we have a question. A die is thrown 276 times, and the results of these throws are given below. Number appeared on die. Number are 1, 2, 3, 4, 5, 6. There are 6 possibilities, and its frequency. Frequency is the number 1 come 40 times, and number 2 come 32 times, number 3 come 29 times, 59, 57, and the last one is again 59. This is given to us. Test whether the die is biased or not. This is we have to test. Die is biased or not. But we shall always take that die is unbiased. And its alternative will be the die is biased. So under the null hypothesis, the expected frequencies we can calculate. The expected frequencies are denoted by EI. This will be the possible number of times, that is 276 divided by the faces. 6 faces on the die. This is 46. So to find out chi-square, also the given frequencies are set to be as OI, observed frequencies, and this is EI. EIs are calculated or expected frequencies. It is clear that is it is always 46. So You can write down 46 in each of the case. Now, how to compute chi-square? And there is the formula. The formula is that is a summation. This is the formula we need to use. That is a sigma OI minus EI whole square divided by EI. This is we have to do. And you know what is the meaning of sigma? Sigma means the sum total. So OI minus EI, the first value is 40 minus 46 whole square and divided by 46 plus. The second value is 32 minus 46 whole square divided by 46. And the last value is 59 minus 46 whole square divided by 46. So you will calculate the sum total of this, and its sum total is calculated as 21.30. So this is the calculated value of chi-square. Now we have to find out the table value of chi-square at 5% level of significance. So you will calculate the table value for n minus 1. What is n here? 6 minus 1 is 5. 5 degree of freedom. And this value is 11.09. Clearly, calculated value is bigger than table value. So therefore, the null hypothesis is rejected. It means the die is not unbiased. Die is a biased die. So this is the procedure to apply chi-square test. Now, let us apply this test for computing it for a best fit. Best fitting will be done for the case of binomial distribution as we have discussed earlier. For both distributions, either is binomial or for Poisson. So first of all, binomial distribution will be discussed. The question is record taken of the number of male and female births in 800 families. Male births are there, female births are there, and families. Families mean total families, and total families are 800. So 0 male and 4 female, 1, 2, 3, 4, 3, 2, 1, 0, and the families will be written over here. That is 32 and 178 to 90 to 36 and it is 94. What does it mean? There are 32 families in which 4 female children have taken birth, but no male children have taken birth. But 172, 78 families are there in which 1 male children and 3 female children have taken birth. This is the case. Test whether the data are consistent with the hypothesis that the binomial law holds and the chance of male birth is equal to female birth. This is we have to check that P equal to Q equal to 1 by 2. Mean there are equal chance of a male child or a female child. Now this is we have to do, and this is the question of binomial distribution, and we shall find out the probable distribution. And these are the observed frequencies given to us. Now we have to calculate the calculated frequencies are expected EI. It is denoted by EI. And let us see that 0 male children have taken birth. The formula will be 800 multiply probability x equal to r will be used. And you know the formula for binomial distribution, probability x equal to 0. So that will be n C0 and n is 4, 4C0 1 by 2 raised to power 4, and you will calculate it into 1 by 2 raised to power 0. So this comes out to be 50, and similarly we can calculate n1, that will be 800 into 4c1, 1 by 2 raised to power 1 and 1 by 2 raised to power 4. So this comes out to b. This is 200. You can check that. This n2 will be calculated. This will come out to b. 800 into 4c2, 1 by 2 raised to power. This will be 1 and 2. 1 by 2 raised to power 2 again. So this comes out to be 300, and 3 is to be calculated. This comes out to be 200, and 4 is come out to be 50. There is symmetry in the value. Always be symmetrical value. 50, 200, 300, 200, and 50. So this is the way. And clearly the total come out to be 800. You know that it should always be, because the total families are 800. This is we have this. Now the data has been calculated, and you can find out OI minus PI whole square divided by 1. So this is the procedure to compute the chi-square, and chi-square is the sum total will be used. OI minus PI whole square divided by PI. You can compute, and it comes out to 454.433. Now, chi square at 5% level of significance for degree of freedom is 5 minus 1 is equal to 4 degree of freedom is 9.49. So calculated value is greater than tabulated value. Null hypothesis is rejected. Now, rejected means there is some kind of unfair play behind the birth of the children. That the birth of a male child and a female child is not homogeneous. So we can say that the data is not consistent. So this is the testing of the binomial distribution, whether the binomial distribution is a best fit or not. In this case, it is not a best fit because data is rejected. Null hypothesis is rejected. And why it is so? Because the calculated value is come out to be greater than tabulated value. That the probability of a male birth and female birth is not equal. This is a very important question of a student. You can practice more questions related to binomial distribution. Now, come to a Poisson distribution. And for Poisson distribution, we have simply given the data value, and they have said that fit a Poisson distribution and test the goodness of fit, whether this is a best fit or not at 5% level of significance. X is given to us 0, 1, 2, 3, 4. Frequencies are given 419, 352, 154, 56, and 19. And its sum total is come out to be 1000. You can check. And you know that in the formula of Poisson, the Poisson distribution is probability x equal to r is equal to m lambda power r e power minus lambda over r factorial. And in this case, r come out to be 0, 1, 2, 3, 4. So from 0 to 4, you can put. And before this, we need lambda. And lambda, you know that in Poisson, this is the mean. Sigma fx divided by sigma f. That is 1000 you can find out f into x, right? And take the total. That come out to be 902, 904. 0.904 is the lambda. And now we can find out the expected frequencies. This is observed frequencies given to us. You know that OI. This is OI. And we have to calculate EI. And how to calculate EI? That will be uh, probability x equal to 0, that is multiplied by 10 in 1000 into e power minus lambda into lambda power r, it is 0.904 raised to power r. R is 0 here, e power minus 0.904 divided by 0 factorial, and it comes out to be 404.95. Similarly, probability x equal to 1000 into 0.904 raised to power 1, e raised to power minus 0.904 is 1 factorial, e 66.08, and the probability x equal to 2 will be calculated. It comes out to 165.468, similarly 49.26, and this one 11.26. Now you can round off the values and see the total. So if the total does not come out to be 1000, suppose in this case, this is the round of value 405, this is 266, this is 165, this is 50, and its value is 11. That is the total we are getting: 5, 6, 11, 5, 16, and 1, 17, and 2, 5, 7, 13, 19, and 47, 1, 8, and 1, 9. So we are getting 997 value. This is not exactly 1000. So for making it 1000, you will add 3, because 3 is less than 3 value. It is less than by 3. So you will add 3 in the last value to make it 1000. You can do it. For testing it as a best fit. Just to make it a best fit, you can do it. Now you can apply chi-square. This is sigma OI minus PI whole square divided by EI. This will be the sum total. And what is your first value? First value, that is OI, it is 419. And calculated value is 405. Divide whole square, it is divisible by 405. So this is the way to compute the sum total, that is 19 minus 49 square divided by 40. So this is the way to compute chi-square. This comes out to be 2.587. Now you can compute the table value at 5% level of significance, and the degree of freedom is how to calculate the degree of freedom, because there are data values are 5, and you have to subtract 2 from the data value. So this is the 3 degree of freedom. So the table value is 7.815, and calculated value is less than table value, so null hypothesis is accepted. That fitting is the best fit. Fitting is the best fit. Poison fitting even. Poison fitting is the best fit in this case. This is the procedure to compute the fitting question. It is very important question. Binomial and Poisson both. You have to apply this. So this is all about fitting. Thank you very much. I stop here. We shall continue in the next class.